dividing whole numbers by fractions. As an example, Phil had sliced 4 apples into fourths. How many slices does Phil have? Here we have the 4 apples that Phil is faced with. He wants to slice them into fourths. What Phil would like to know is how many pieces of this size does he have in all these 4 apples? Well, we know if it's sliced into fourths, this apple would have 4 pieces, as would this one, the third, and the fourth. If there are 4 pieces in each apple, Phil would have 16 slices of this size, or 16 fourths of an apple. If we look at this problem on the board, Phil had 4 apples that he divided into quarter slices. The rule on this would be, when dividing by a fraction, invert the number on the right and multiply. So for our problem, we had 4 apples that we were dividing into quarter slices. If we follow our rule, we're going to take the 4 apples, invert the number on the right, and then we want to multiply. In order to do a good job on the multiplication problem, we want to change this number so it's a fraction as well. Our whole number 4 can be rewritten as the fraction 4 over 1. So our problem 4 divided by 1/4 becomes 4 over 1 times 4 over 1. That has a value of 16 over 1, or 16. That's exactly what we would expect to happen. When we divided our 4 apples each into quarter slices, we knew that we would have 16 pieces of apple. As another example, if there are 2 pies and you want to slice each one into 8 pieces, how many slices will there be in all? We have a piece here that we want to make sure that we're going to divide the pie into a lot of pieces exactly this size. This represents 1/8 of a pie. We have up here our 2 pies, and each one is divided into slices that are 1/8 of the pie. We notice that each of the pies has been divided equally into this size piece. We have 2 pies divided by 1/8. We'll use the rule and say we want to invert the second number and multiply. We'll change our whole number to a fraction, 2 changes to 2 over 1, and we'll invert or flip the second number and multiply. When we multiply these, we get 16 over 1, or 16 pieces of pie. So when we took our 2 pies and divided them by 1/8, that would give us 16 pieces of pie.
This is a computerized trimming machine in a printing plant. A cutter comes down and trims the paper or cardstock. To make certain that all pieces of printed materials are the same, the stacks of printed paper or cardstock gets trimmed. Notice that even the stacking of the trimmed stock is automatic. Say this machine can trim 600 pieces of cardstock in 1.5 minutes. How many pieces of cardstock can it trim in 1 hour? Let's figure out this problem. The trimming machine can trim 600 pieces of cardstock in 1.5 minutes. And the question is, how many pieces of cardstock can be trimmed in 1 hour, or 60 minutes? So let's first of all find out how many pieces of cardstock can be trimmed in 1 minute. So we divide 600 by 1.5 equals. So 600 divide, let's change this into an improper fraction, this mixed number. So 2 times 1 is 2, plus 1 is 3 over 2. Now let's invert this number, then multiply. 600 times 2 over 3 equals, and we can use cancellation. 3 goes into 600, 1, and this will go 200 times. So 200 times 2 is 400 over 1 equals 400. So in 1 minute, that machine can trim 400 pieces of cardstock. Now let's just multiply 400 times 60. Bring down the 0. 6 times 0 is 0. 6 times 0 is 0. 6 times 4 is 24. So in 1 hour, this trimming machine that trims 600 pieces of cardstock in 1.5 minutes, in 1 hour it can trim 24,000 pieces of cardstock.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.